The idea is Jannah is a profit venture. As we go into this venture or this journey, the end goal is to make money and to educate and to learn and to have some fun doing some serious software engineering. So the main backbone that we need for our basically machine learning pipeline is a tool called Kubeflow. Kubeflow is basically how you create workflows for machine learning, right? But of course, it's called Kubeflow because it's done on Kubernetes, right? So the idea is Kubeflow gathers all the best tooling for processing data in the name of machine learning, right? So before Jannah is deployed, Kubeflow is first deployed. And once Kubeflow is up and running, Jannah will then be deployed. And then Jannah will use Kubeflow to model itself and to learn itself and to become a self-aware platform that is learning and smart, basically an AI environment. Okay? So that's the overview of what we're trying to do here. So the operator is on GitHub. So if you want to check us out, so our website for the Jannah operator is, so we're on the internet at www.jannah is JANNAH.io, right? So check us out. But what you're looking at here on the website is a blueprint. Over time, this blueprint will be beefed up. The idea is every component you see here will turn into a full-blown feature within Jannah. And then there will be subsequent videos, of course, where we showcase all of these pieces together over time in a journey-like way. We want to tell stories, but we want to tell stories about developing software using best practices, using the best techniques in industry as far as data science, as far as blockchain, as far as good old software development. Okay. Our operator, though, is based on a tool called Charm. So what Charm lets you do, Charm let you create Kubernetes operators using the Python language, right? So right now in industry, there are 3 ways you can create operators. You can create Go-based operators that are written entirely in Go, because most of Kubernetes is Go anyway. You can write operators using Ansible Playbooks, where basically what you're essentially doing is you model your day-to-day management of your application using Ansible plays, and those plays are run when your operator is deployed on a cluster. So what we're kind of doing here is that's the middle way. We're using what's called a Charm operator, which is basically a framework for building Kubernetes operators using Python. But because we had previously already written a lot of playbooks for deploying our component, we're basically taking our existing Ansible playbooks, we're wrapping them with a Python library that will then fire different plays based on what we want to deploy into a cluster. So we're using Charm operators. If you want to get familiar with that, check them out. They're pretty cool. So the idea is you would have a client sitting on your local machine, your laptop here. That client is talking to clouds. You could have X, Y, Z clouds. You could have many clouds. And from your one computer, you can send commands to each one of those clouds to deploy various services and component. So that's the idea, right? So you would take the day-to-day activities that a human being will do, like a system admin will do to manage an application on the cloud. You would then encapsulate all of that day-to-day task into an automated script. And that automated script is basically what is called an operator. So an operator is just a fancy word for an app that manages another app. So in our case, we're building 2 different apps. We're building the Jannah Accelerator, which is our main app. But to manage our accelerator app here, we would also create a Jannah operator, which is basically, I don't want to get up every day and log into a cloud and manage the Jannah platform myself manually with my hands. So what I'm doing, I'm automating what I would typically do on a day-to-day to manage Jannah. encapsulate all of that into an operator that I would deploy into a Kubernetes cluster. And then that operator then would then issue commands onto that cluster, like you would see in this picture here. And those commands will be basically running, taking care of the app day to day. Okay. So let's go into actually deploying Jannah. So this is the Jannah code 3 here. One more time, we're on GitHub here. Check us out. So if you go to github.com/Jannah.io, so it's JANNAHIO. So that's where we are on GitHub. So this is the actual Jannah operator on GitHub here. Okay. It sits with 3 other code bases. So there's a front end app that would be the front end application for Jannah. That's a Vue.js application. There's a middleware app that would basically supporting the front end application with all the data and compute power. And then middleware app also depends on a storage app that actually provides storage mechanism for keeping data over time. Okay. So let's actually get to the demo itself. So what I'm going to do here, I'm going to first wipe out the existing Jannah infrastructure that exists. So this is what we have already sitting into our cluster here. So if I do a kubectl get pods, okay, so this is from a previous deployment. So the beauty about using a tool like Molecule, it provides what we call an end-to-end deployment, right? So it would say, oh, you had previously deployed something here. Okay, so before I deploy something new, I'm first going to wipe out. So there will be a destroy phase where we clean out everything that was previously deployed, and then we will then recreate the entire infrastructure. So we will create a new cluster, and into that cluster, we will then deploy all our necessary components, and then deploy a fresh, brand new Jannah environment. Okay, so what I'll do first, I'll say make clean. So here's our make file here. So there's a make file at the top of Jannah, right? So I'm first going to do a make clean. So under this make clean target, what it does is first do a charm destroy. So it will destroy the previous infrastructure that was there. It will destroy the previous Python virtual environment that we have. And then I'll do a make charm converge. So what this will do, so let's take a look at the actual Ansible playbooks that would be fired for each one of these make commands. So here's our charm. Charms come with a file called charmcraft. So part of our deployment is we will build the operator container to on Ubuntu 22.04. So we'll build it to account so that it can run on AMD 64 architecture. We'll also build it so it can run on also ARM 64 architecture, right? So AMD 64 architecture, this is the traditional Intel-based chip, right? This ARM 64 architecture. These are the new Mac M1, M2 chips, right? So the idea is because we're using Macs to do day-to-day development, we want our operators to be able to deploy on a Mac M1 machine, but also to be able to deploy on Intel-based machines. So what this file does, what chamcraft.yaml does here, it says, okay, bundle the operator such that we can deploy it on AMD 64 architecture, or we can deploy it on ARM 64 architecture. So the idea is we build with this architecture and we run on this architecture. So we should be able to build on AMD architecture and run on AMD. We should be able to build on ARM architecture and run on ARM architecture. Okay, so the actual source code for the charm is here. So this is what a Python file is. So this Python file is an event-driven machine. What it does, it says, okay, what are my pieces for this operator, right? So what does this operator comprise of? So in this metadata file, you'll see, because we're starting this journey early in the journey, so right now there's two main pieces of these two containers we want to